body and fundamentals is coached by 85% of coaches regularly. Many coaches are well trained and the well of resources is unlimited for various drills, plays, and information. Recently, emphasis on preventing injury has become more popular, and thus more information has come out for coaches on ways to help their athletes. Exercise physiology is the body's response to physical activity and how the body adapts over time. Exercise forces the body to adapt and change in homeostasis and change to become more efficient. This is important in sport, but also by creating conditioning routines for your athletes, you help to prevent long-term diseases like heart problems, diabetes, and more. There are two types of physiology, sport and clinical. Sport physiology applies concepts of exercise physiology to enhance sport performance. By looking to understand the demands of basketball on one's physiology, we can understand what characteristics on an athlete needs to be successful. Exercise alters the structures and functions of the body. You will deal with both acute and chronic exercise as a coach. Acute exercise is an individual bout of energy, such as 30 minutes of conditioning practice in the preseason. Chronic exercise is repeated bouts of exercise, such as practicing 5 days a week per season. You will also see both aerobic and anaerobic exercise. It is important to understand how athletes contract their muscles. The athletes must be able to release energy from the ATP molecule. There are 3 ways in which the body can do this. The first way is aerobic. This means plentiful oxygen in the body, and using oxygen, the glycolysis, Krebs cycle, and electron transport chain are used to release energy. When the body is working hard and using the oxygen needed for ATP, the anaerobic system is used to release energy. Lactic acid is formed from anaerobic systems, and the lactic acids present forces the process to stop. Glycolysis can be done with or without oxygen. Your athletes can only store 5 to 10 seconds worth of energy without the help of anaerobic and aerobic systems. Glucose turns to ATP to help with creating energy, so it's very important your athletes' glucose levels are at a good number. After 5 to 10 seconds, the body begins to use glycolysis, the next quickest generator of ATP, giving the body 15 seconds of energy. Next, the body, if oxygen is present, uses the Krebs and electron transport chains, which are slower than glycolysis but create more and more ATP. Coaches working with young athletes must emphasize the importance of getting enough fats, carbs, and proteins in an athlete's diet so they are able to create energy. When ATP is greater than the body's need, glycolysis shuts down and lactic acid is formed, which is detrimental. So your athletes must be well trained in cardio so that they are able to properly use all 3 systems. In this system, oxygen is very important, so testing your athlete's VO2 max is important before conditioning players. A VO2 max is the ability of the body to transport and use oxygen. Athletes need to transport and use oxygen in their aerobic systems effectively. The more CO2 you expel, the closer you get to anaerobic exercise. This leads to quick fatigue. To find the VO2 max, use this formula. When evaluating the results, keep in mind that an average college man has a VO2 max of 45 or 35 for females. Elite athletes can reach the 80s and 90s, but your youth athletes will be much lower. To test VO2 max and oxygen use first produced, most elite coaches use machines. Without machine testing, it is possible if you use a 1 to 10 scale and ask the athletes how tired they are after conditioning. You can track improvement from there. Coaching youth female athletes come with the hormonal challenge. A girl's hormones fluctuate based on her menstrual cycle, especially during puberty. This will fluctuate results. Oxygen is transported by the cardiovascular system seen here. It is also important to understand how the cardiovascular system is working in order to help oxygen move to ATP for energy. There are 8 functions of the cardiovascular system. First, transporting oxygenated blood to the skeletal muscle. Second, transporting metabolic substrates, which are cells that we are using the blood to break down and produce energy. Third, to remove metabolic ends products like lactic acid. This function is very important because in order to continue exercise, waste must be eliminated. Fourth, to regulate pH. As the exercise intensifies, the body gets more acidic. The fifth is to transport hormones, which is released after about 50% VO2 max helps the body produce more during exercise. The sixth is to maintain fluid volume. The seventh is absorb and redistribute heat. And the final function is to improve the immune system's function. Energy is needed for exercise, and it is very important that oxygen is being produced and transferred correctly. Energy not only helps metabolic activities, but also to maintain a homeostatic body temp and to improve physical performance. As we know, ATP is stored in muscles and produces muscle contractions. We also know that this is limited, and when it runs out after 5 to 10 seconds, the body moves on to the next energy source. Your athlete will use the ATP PCR system or the anaerobic system when jumping or shooting, because this system is for power strength movements of 5 to 15 seconds, in which the body can simply use ATP. Your athlete will use the glycolic system for transition play, in which they need 1 to 2 minutes of quick energy. Carbohydrates are broken down to create ATP, but hydrogen and lactic acid are released, meaning your athlete will be very tired after those 1 to 2 minutes. For energy for an entire game or practice, your athletes will be using the oxidative system, Krebs cycle, or electron transport. It takes a while to produce the ATP, but can last beyond 2 minutes. How long depends on how conditioned the athlete is. Coaches can do activities to improve each system. Working your athletes on explosive movements like jump squats will improve the ATP system. Circuit training with little to no rest will improve the glycolic system. Low-intensity timed cardio helps improve the oxidative system.